For anybody who I can't imagine doesn't know Bob Rusczyk, he's unemployed now. If any of you guys are
Retired.
so talking about NEC and everything you need to know.
Or not.
Or not.
Okay. We'll roll back a few years in time. There have been a couple incidents in the industry. It fell apart.
Yeah.
Okay.
Shit.
Broke. Defective. Couple incidents. I don't know if anybody's kind of tracked the incidents that have taken place in the industry, but about 5 years ago, a major incident kind of got a foothold, and that was a project up in Wisconsin, in which an organ builder from out of the state of Wisconsin, way out of the state of Wisconsin, was confronted by a local inspector. It became the proverbial pissing contest. Ultimately cost the organ builder and possibly the church thousands of dollars and many months. And most of it was hair-splitting technicalities. Anybody know the name Scott Walker? A few of you do, okay. This was all on the heels of the whole union bust that took place in Wisconsin. And why I bring this all up is this kind of leads towards this. Where do electrical inspectors come from? Electrical inspectors come from previous lives of union electricians, okay? So the code as it stood up till this latest revision was a cakewalk, and still is a cakewalk. What we're going to address is the current code that goes into effect in January. This is the 2017 code. And as we go through, there are parts that will be highlighted as we walk through the code that tell us what the revisions are. But basically, to put it in perspective, this is the National Electrical Code. Okay, it's 850 something odd pages. That square is our portion of the National Electrical Code, to put it in perspective. Okay, our portion of the National Electrical Code is about a page and a half. Now, it's been parsed out so we can walk through it here. But it really is a very, very simple to comply with exercise. And it is really all based on logic and proven methodologies in, we'll say, more robust industries. I can't stress enough, if you have the opportunity to thank Art Schlater Jr., you need to buy him dinner, send him alcohol, whatever you like, and thank him for his 25 years of keeping the wolf outside the pen. Art managed over the last 25 years to keep the organ industry, specifically the pipe organ industry, from being sucked in to the low voltage portion of the code, okay? Which is, what, 70, 80 pages?
Yes.
Yeah.
About a tenth of it.
Yeah, I mean, it's a large portion of the code, and organ building as we know it today would not exist if we had to comply with low voltage portion of the code. Give you an idea what and why that is. The low, yes?
I was going to suggest you open a window so that everybody doesn't fall asleep after lunch.
Or turn the air on or something,
Get some cool air in here.
so.
Just a suggestion.
I think Taylor and Booty would survive. I don't know.
Well, Bob giving a lecture.
Thanks.
So, yeah.
Thanks, Alan, that's low.
Oh!
I quit. The low voltage code is only a few steps away from full-blown code compliance. Double shielded conductors, encased raceways, so on and so forth. To be honest, practically, financially, we couldn't even dream of complying. Even in complete new instruments, it would change the color, probably add 25-30% to our cost. So understand that that's a point to, again, thank Art. And I'll digress. Both presidents please find another person to be our Art. Art has, for those who don't know, Art has wheeled his way out of this. He's up, Art's in his 70s and trying to retire too. So we need to still defend this, and we need to defend it from the organ building side of the world and not let other people get their fingers into driving this process. The code is, as next line says, it's about personal life and property safety. That's all this is about. They don't care about your organ, to be point blank. No portion of the National Electrical Code is there to care about anything other than truly safety. Okay, it is your friend, though the source of the code is not a regulatory agency. The writers of the code, and the code itself is not per se itself a law. Probably 95% of all jurisdictions in the United States adopt the code, or in some places, a more stringent version of the code, their own. Pick major cities, they have their own that they've rewritten, and in many cases, it's more stringent than the code. So, it is the law, even though the source of the code is not an enforcement agency. Your local enforcement, city, county, so on, township, they are the people. And call them up and ask them if you ever have that question, call them up and say, do you comply with National Electrical Code? And don't even get into which section, just ask the question. And 95+% of the time they're going to say yes or some derivative thereof. So what that also says, it's not optional. Okay, it truly is not optional. It is proven. It's based on proven. Oh, raining. Better than snowing. It is also your get out of jail free card. You may not think about it as that, but if you were to have an incident, an injury, fire, etc., that is a result of electrical work you've done on an instrument in a building, if you have complied with the code, you're going to make the insurance company happy. Okay. Fire inspectors get involved. Fire inspectors go looking at code and so on and say, oh, well. So ultimately, it's trickled down to the source. And that last line, it is not a joke. Do you have at least $1 million of liability insurance in your business? I mean, think of the buildings you work in today, and think of how easy it would be to generate $1 million worth of damage in a building today, let alone personal liability if somebody were to be injured. So just bear that in mind. On to the code. It really is very, very simple. It clearly states what the code is about. Covers all the electrical circuits and parts of electrically operated pipe organs that are employed for the control of the keyboards, the sounding apparatus, and typically organ pipes. The parts in blue are the changes to the code for 2017. They're mostly nuanced type changes. So there's two issues we'll get to, but mostly they're nuanced changes. Informational note, they're just stating, hopefully for clarity to those who are enforcing the code. Because this is part of the problem that has been brought to light. I know Dobson's and Birmingham had an issue about 3 years ago where inspector again came in, got fingers into it. They weren't prepared to be able to cite what their point of reference was. And I stressed that, I'll stress that over and over again. Make sure you have copies of this. You now have copies of it. But make sure you understand what it says. And be able to cite it politely. If somebody confronts you, hey, we have section 650 of the NEC, article 650 of the NEC. That's what we work to, and be able to present it. And it's just, they're defining what it is. 650.2, this is an entirely new section. Previously, it just stipulated what a pipe organ was. now they are breaking this out because of the now commingling of digital instruments, hybrids, so on and so forth, which, oh, by the way, those types of instruments, digital instrument actually has its own paragraph or two in the code, okay? And it's I've got it noted further down. But just understand your the definitions. I'm not going to walk through all those, or we'll be here all day. Other articles, and this is truly a get out of jail free card, and I do not know how Art managed to get that new paragraph in, okay? But that new paragraph basically says 650 supersedes every other part of the code, okay? The problem with that is, and Bill and I were having this conversation, is that 650 is actually in contradiction to parts of the code, okay? It is not as stringent, and again, it is in contradiction to parts of the code. So understand that you do have that paragraph to fall back on, which basically says 650 is if the electrical code is adopted by your regulatory municipality, then this is what pertains to pipe organ. And it goes on to stipulate if it's an electronic instrument or there's additional analog, digital, so on and so forth. 640 kind of spells that out, and it basically says how to plug things together and not electrocute yourself. And then optical fiber is in 770 of the code, and it's also a very brief section of the code. Next section is where we differentiate between low voltage code. The first sentence there. We are 30 volts and below. Low voltage code covers up to 50 volts. Okay. This is part of how we do get the special handling. So anybody who's out there thinking about doing what Ken Chrome and I know a few other builders have done over the years and put 48 volts in a console to operate custom wound Syndine stop actions and so on and so forth, that automatically takes you out of 650 of the code. So as long as you're 30 volts and below, you're good. You know, they've added this informational note. You know, class 1 power limited supply are often utilized by part organ specifications, and that is just what Dick referred to this morning. These are all class 1 limited supplies.
Bob, it says listed DC supply. I presume that means listed in possibly like UL or CE listing.
Yes. The next page, and this is again differentiating between low voltage code, general code, and us. And this is new language and some rework of the language. Double insulated power supply or grounded. Again, Dick touched on a lot of this today, but if your cabinet from your power supply is connected to that ground prong that goes into that wall, you comply. Okay, it is now grounded. It is now a grounded device in the eyes of this regulation. You know, if you do not have it, then it needs to be double insulated, which is a whole other realm of packaging and so on and so forth, and something that I don't know of any power supply that we are using or that barely even exists today that fit that criteria. So, but they threw it in because there are evidently some examples out there.
Wall warts.
Yeah.
Things used inside the console.
So, and again, 2, right there. The case is connected to the third prong. Conductor size, and this is a change, which is kind of interesting. minimum conductor size, 28 American wire gauge. Pay attention to that, because that says for signaling non-resistive loads only. Okay? So you cannot drive a magnet with 28 gauge wire. Okay? That is only for signaling, and examples of that would be swell motors, control on and off circuit on a trem, not powering the trem. And I know people who cheat and power the trem in the on and off circuit through the same lead coming out of the control system. Okay? And I mean, theoretically, most control systems will handle that load. Okay? Might be a half amp, whatever. But no more cheating. Yes?
Could you say that again?
Okay. A trem driver,
Right.
like an OSI trem driver or an ARNT or whomever, that has an input circuit to turn it on and off versus power input to it to actually drive the output side of the driver. Okay, I know a lot of people over the years have cheated and just taken that stop tab output and shoved it into both. Okay, and it works. Be honest, I've done it. Okay, so that now disqualifies this at 28 gauge. Now you can do it at 26 gauge if you want, or 24. I mean, you can still do it, but if you're going to signal it separately and have current separately to it, it is two distinct views. Swell motors, the inputs for swell motors, like on an OSI or a Peterson or a lock-off, the inputs, the control inputs, the signaling inputs, they can be 28 gauge. I mean, I don't know what, to be honest, I don't know anybody's using 28 gauge for anything anymore, but if there's something grandfathered, something that's there that you're trying to reuse, just remember you cannot put a resistive load like a magnet on 28 gauge wire. And then 26 gauge wire, everything on down. The next interesting piece is they've now dictated the minimum conductor size for your returns. Okay? It's 14 gauge. And there's a couple gotchas further down that I outline, but I'll touch on them. One of them is foil tape. Okay, you guys like to use the copper foil tape? That's considered to be a main return. You need to make sure that the copper tape, that foil tape, is the same current carrying capacity or resistance as 14 gauge wire or larger, being 12, 10, etc. Okay, so just bear that in mind. Insulation. Standard, every piece of wire out there today is in some sort of thermoplastic or thermosetting insulation. I don't know of any wire you can buy commercially. There are some oddball manufacturers who make specialty wires for like the lamp industry and so on. And how they do what they do, I don't know. That's not our business. But any wire you buy today is going to comply with this. Telecommunications wire, which is your normal bill of fare, that's all that whole package there. Conductors to be cabled. And again, this is stipulating a difference from every other aspect of the code. So we can bundle our common in with our other direction. Okay. And it's basically all they're doing is saying we can common returns under additional covering or with the cable, either or, because it gets separated. Take a stop action set. You're running your commons, say on a Syndine or an OSI tilt tablet. I know a lot of the guys who just solder all their commons together across, and then bring everything out. So it allows for the separation or the binding together of your common. Conductors, again, cable covering. Each cable shall be provided with an outer covering, either overall or on each of its subassemblies or group conductors. Again, jacketing of cables. That's all they're referring to here is jacketing of cables. Tape shall be permitted in case in lieu of covering, so you can continue to use your tape. Make sure it complies with the flame retardant standards. Okay, and I think the product that OSI does sell complies with that. Standard 88 tape complies with that, though God help us, nobody wants that in an organ. There are friction tape products that all comply with that. Make sure you have a product that complies. At one point, OSI was selling more than one version, and one was and one wasn't. This goes way back. You don't need to go do your testing. All you need to do is make sure that you buy, whatever you're buying is compliant, and pretty much any cable you buy today is going to be compliant. Again, installation of conductors, and this is where things get interesting. Separation from us from the rest of the world. In the rest of the world, everything has to be in something. Okay, all your distribution all has to be in something. In our world, and we're going to get to the very end of this, where we stipulate what a pipe organ is, which is interesting. But everything should be fastened. They don't stipulate how to fasten, which kind of bothers me, but you know it's reasonable and rational. Okay, I know people like to use tie wraps. Okay, cable ties. Cable ties are a marvelous thing, but tomorrow we're going to talk about how cable ties aren't a marvelous thing. Okay, it's why they make tools for cable ties that, when you're properly adjusted, will not damage the cable. I know you guys like to cinch this stuff up good and tight. That's not good. Okay, those are places where, depending upon how much weight's on the cable, how much vibration exists, and so on and so forth, you can now end up with shorts, cuts, opens, and jackets, and so on. So just be aware. Again, the blue is new language that stipulates we are exempt, or different than the rest of the code. I won't say the word exempt. In which you can attach directly to your organ. Okay, framing, chests, whatever. In no other industry is that allowed. It has to be somehow jacketed and encased, so on and so forth. Here's one that I don't know anybody, I've yet to see anybody actually do, and it's been in the code for a long time, at the very bottom. Abandoned cables that are not terminated, identified with a tag. Okay. I've been in more organs where there are abandoned cables, and there's nothing to identify. It's what's this, and what was it? If you're involved, tag the cable. And oh, by the way, in the manila folder was a sample of a cable tag, and also the sheet that you can make those from. Okay, so you can use it for your regular cabling, and in this case, all you do is write abandon on the tag. So all you have to do is write abandon on the tag, and that makes you legal and safe. Both ends of the cable have to be tagged.
Thank you.
Okay? Both ends. Okay? And if you don't know where the other end is, get yourself a toner and figure it out. Okay? Because again, if there is an incident and somebody goes shopping for a reason for an incident, okay, your untagged cable could become, oh, well, I tied onto that cable, I didn't know what it was for, and the other end started a fire. So
Abandoned cable should not be live under any circumstances.
that's right.
So just because you have one end doesn't mean you don't
Yeah.
have the other end.
Yeah, both ends need to be tagged and noted as abandoned. Okay. And in my world, I came out of the telecom world where we not only tagged it as abandoned, but we also noted on each opposite tag where the other end was. Okay? So if it's in this room, in this corner, and such, just a little note to say that's where the other end of the cable is. Overcurrent protection. Here comes the biggie. Major change, and I have that in red for a reason. Up till this change in 2017, that previously read 24 gauge and up. It is now 20 gauge through 28, and stipulating that anything even smaller than 28 is no longer acceptable. So, we'll talk about protection. Protection in the eyes of the NEC is a fuse or a manually resetting circuit breaker. All these solid state devices that all the equipment manufacturers are stuffing into things, I'm not going to pick on OSI, but I'll just say it, and the swell motor, it was designed with 2 chemical fuses in it. One on the input side and one on the motor side. And to be honest, they were put there to protect the motor, okay? Not to protect the wire, okay? So understand that circuit breakers, these self-resetting things that are in control systems, Peterson has them, Syndyne has them, SSOS doesn't have them. There's this idea that, oh, well, we've got this protection that's built in. Well, it's there to protect them. It really isn't there to protect the wire. And the whole goal of this is to protect the distribution network up to the device, okay? Somebody gets something sharp across a couple conductors, especially feeders, you want something to give up the ghost other than the piece of hardware that you accidentally got across it, which if there's something not capable of giving up the ghost, it's going to weld, it's maybe going to melt, it's maybe going to flash and burn somebody. I mean, I've seen tools dropped on large DC systems that make a big enough flash and have burned people, okay? So it has to be something, the protection has to be a device that has to have human intervention after the event. It cannot self-heal, okay? Bear that in mind. Protection from accidental contact. And how they got around this is a great thing, okay? Under every other aspect of this code, that portion right there is everything's in a box, everything's in a trough, everything's in a conduit, everything's in something, okay? They consider the organ the box, okay? So now also bear that in mind. The catch to that is your control system needs to be behind a locked door, okay? Your rectifiers, your power supplies need to be behind a locked door, okay? Your console needs to be not easily accessible. I mean, they're not going to say put a lock on it, but, you know, you don't want somebody to be able to pull the side of the door up, if you have a door on the side of the console, pull it open and reach in and get to the power. That would have to be locked. Normal consoles, hey, you got to take it apart, they're not getting in it anyhow. But just bear in mind that any portion of your wiring has to be pretty much under lock and key, one way or another. Inside the organ case, inside the organ chamber, hey, stuff it in the swell box, whatever you want to do. But that's the code, believe it or not, in 33 minutes. Now we'll get into application. And I call this application without brain cramp. Okay. Some of it I've covered, but we're gonna walk through it. You know, the commons, bear in mind the commons. Just comply with it. Fusing, and this is gonna become a great source of conversation this afternoon. Peter and I have gone round and round and round for several years discussing what constitutes enough for a rank of pipes. Okay? Wherever we end up, it doesn't matter. If you decide you want to be able to play, and Dick touched on this earlier, if you want to be able to play all 97 notes of that unit tibia on that Wurlitzer theater organ, then fine. It's your prerogative to provide enough protection for that, okay, in 6 amp increments, okay? And there's the ticket. Everything from 20 gauge and smaller, the maximum fusing is 6 amps. Now, and that, if you, on your spare time when you have nothing to do, dig up the couple of the references I make in my documents, you can run some of these numbers through some of these calculators, and you'll sit there and say, how on God's green earth is 24 gauge applicable to 6 amps? Okay? And for all practical purposes, it really isn't. Again, this is one of these contradictions. Okay? It's talking about cabling. There's areas of the code that talk about how many conductors in a cable and derating of cable. We dodge that bullet because theoretically, at no given time, are we running a long-term constant draw on 64 wires and a 32 pair of cable. Unless somebody, again, has pulled the stops, pulled the couplers, and laid the 2x4 down, and put the concrete block on it, and walked away from it, okay? It's how Art managed to navigate a lot of these gotchas in the code is by stipulating our non-normal use. And we are very non-normal. I bring up the fact of, we'll get further down. But I bring up the fact of how many, typical worst case, 2 hands, 5 notes each, okay, on different notes, which isn't going to sound pretty anyhow. All couplers pulled. And I'll give, okay, throw 4 more notes in there, make it 34, because I got my 2 feet planted on the pedal board, and I've got whatever stop that is pulled in on 2 intermanual couplers. Okay. For all practical purposes, the load is 30 notes. Peter will tell me it's probably 40. So. But the long and the short of it is, in order to meet that 6 amp requirement, now you got to go do the gymnastics, as Dick talked about earlier. Run the math, and I've got 5 examples we're going to run through in the back of this. Run the math, it's very simple. And oh, by the way, I'll warn you right now, I rounded everything up. Okay, I don't sit here in hundredths of an amp. Don't care about hundredths of an amp. To be honest, I really don't care about tenths of an amp in the grand scope of things, okay? I care about being able to protect to meet the code compliance, okay? And that is in 6 amp increments on anything on a wire 20 gauge and smaller, which is 95% of the organ, okay? So it may be, if it's a rank with 140 ohm standard chest magnets on it, it may only be 1. But if it's, I'll use that word, direct electric, there's nobody from Wix in here, right? Then it may be 3 or 4 returns, depending upon the use of the stop. Okay? So, think towards practical application, not pure, I have all these pipes, and as Dick said, are we going to put power supplies in? You aren't going to put enough power supplies in to play every pipe in the organ, nor do you need to fuse to that eventuality. So let's see, I pushed the down button. Other loads. Sliders, swell engines, They all have to be protected. I'll reiterate, every piece has to be protected. And remember, protection, fuse, or manually resetting circuit breaker. Okay. And actually, I think it's in section 240 that actually spells that out if you dig into the code. All kinds of free apps. That's all I do. I got a couple apps that run current calculations. There's a couple great, in the presentation, there's a web address for a company, Blue Sea Products. They make electrical for boats. They also make marvelous fuse protection systems for us. You're gonna see a lot of that at Canandaigua. Yeah. Yes?
Is this slider motors, fuel engines, is this in addition to the fusing that they already have?
Yes. You have to fuse the wire. The wire, what color, Dick? What color?
Oh, how about red?
Power supply. Distribution. From that distribution, you have two inputs to your slider motor. Well, one's from the Oregon relay side, okay, and that gets a fuse, 6 amps or less. And then you got your feeder side. If you're 20 gauge or smaller, you can be no greater than 6. If you're bigger, you can be whatever you want. But ultimately, the obligation is, and that distribution is just fusing. It's nothing but fusing. Could somebody grab, there's a board out there on the cart. Grab that board that has power supply and two fuse blocks on it. But protection means protecting this wire, okay? Not protecting the slider motor. Again, we don't care about the slide. That's it. Perfect. Thank you. Yes. Thank you, sir. Move the brick. Basically, what we're doing is coming out of the power supply as close as humanly possible. And actually, from a pure, horrible technical standpoint, even those wires should have a fuse right there. Okay? Just telling you like it is.
Fuse on the way to the fuse?
A fuse on the way to the fuse. Think about your house, and we'll kind of jump sideways for a second. Think about your house. Your electric comes from the street. Out there at the street, at a disconnect, at a distribution point, at an underground box, at a transformer, there's a fuse there. Okay? That protects that piece of cable, underground overhead that's coming to your home. You hit that riser, you hit that meter can, you hit your electrical panel. Here's your electrical panel. Power in from the street, you got a main. You got 2 buses. Each one of those has a circuit breaker. Each step of protection, let's say that's a 20 gauge or a 12 gauge one. So under the code, that's a 20 amp circuit. But that's a 15 amp breaker there. So that's a 14. That's 14 gauge wire. That's a 15 amp circuit. Okay. Every step of the way, you're fusing to the current carrying capacity of the wire. So if the wire is capable under whatever calculation method you use, and there's 100 of them, that's one of the problems with this. You can run the straight math, or you can be logical and conservative and use some of these apps that'll oversize you. But every step of the way, or let's talk the shop as an example. You've got a big main panel that comes in the shop. You come out of that maybe with a 60 onto 6s or 8s, depending upon the difference, okay? That is fused for that wire size there, which that goes to another sub-panel that also may or may not have a main in it. If they're smart, they put a main in it. And then, again, stepping down size by size by size. Again, the object is protect the infrastructure, okay? Voltage drop calculations. I tend to use a couple of these apps to do this. What we are doing pretty much doesn't care, okay? You got a half a volt through a control system. Actually, some might even be a little more than a half a volt, depending upon whose control system and how it's put together. To be honest, a volt of drop out is not going to hurt anything you're doing. Okay. On the control system side, like the system itself, that doesn't run on 12 volts. It runs on 5. There's regulators throughout the thing, and those regulators are typically capable of regulating everything from 5 volts up to 30 volts. Many of them do 50 down to 5 volts. So if you've got a voltage drop that takes your 14 volts down to 13 volts into the control system itself doesn't care, because it's doing its own magic and regulation to operate the electronics and the logic. Because if you were to go in and do a 1% voltage drop or a 2% voltage drop, you'd be buying a whole lot of copper, okay? I mean a whole lot of copper. Your wire sizes are going to go up and up and up. You know, pretend this is a 55 amp. I didn't have a 55 amp sitting in my office. That's an 8. That distance, that'll actually do 60 amps. Maybe run a calc on it. That's a 10, okay? That distance, that'll easily do 40 amps, okay? But again, from a pure technical standpoint, those say that you should come out of that sucker right there and put a fuse there, okay? And then from here to here, there ought to be a fuse. And if you're going more than a few inches, you better just fuse it, okay? And I've given product data in the manila folder for Blue Sea, and they sell all these products. No, by the way, they're all on Amazon, and they're also dirt cheap, you can't stand it. Those fuse blocks there, that's a 6 position standard block, has a common bus, has its feeder, even has a little poker to poke the fuse out so you don't have to get your uninsulated needle nose pliers in there to try to pull the fuse out. Oh. Or your uninsulated screwdriver. And don't say you haven't done it, because I know every one of you have. Holders in the top of the cover to hold fuses, spare fuses. That's $35. Okay? It's capable of 100 amps. Okay? Easy, inexpensive solution. We'll talk about a little bit of differences too. That's standard glass fuse style. Okay? I know a lot of guys are using the blade fuses. Downside to a blade fuse is you pay a 1 amp penalty in fusing. You want to do that 6 amp, you can't get a 6 amp blade fuse. It's 5 or 7.5. Okay? So you might have to put an extra fuse or 2 in if you like the blade fuses. And they too make nice, they make a 6-pack or a 12-pack. And, oh, by the way, I have no monetary interest in this other than I was looking for fuse devices other than the archaic stuff that everybody's still selling in the pipe organ industry, and I'm sitting there saying, God, there's got to be a better way. And there's got to be a cost-effective way. I found that. So, voltage drop, just consider 10%, throw 10% in, okay? Because it's not going to hurt you. It's not going to hurt what you're doing. Okay? You'll save a lot of wire and a lot of pain. We've already covered the Overcurrent protection device, fuse or circuit breaker, manually resetting, okay? Can't stress enough, manual resetting. They don't want it self-resetting, and self-resetting to the point where whatever's causing it to blow causes a hazard or starts a fire. And it's been known to happen, okay? Just what we've been covering. At every single wire size, you need to calculate what that load is gonna be on that wire. Now, you can put a larger wire on a smaller fuse, but you cannot put a smaller fuse on a larger wire. So just bear that in mind. If you wanna put a piece of 10 gauge wire on a 5 amp fuse, feel free, okay? But you can't put a 40 amp fuse on a piece of 10 gauge wire. Okay. Again, use the charts. It'll get you real close to where you need to be. And that's what we just covered. Big fuse at transformer, a circuit breaker at the head, so that if the bus were to go bad or go over current, it's going to trip individual circuit breakers to each step of the way. And basically we're saying the same thing. At 650.8, every step of the way needs to be protected. Power supplies, the new switching power supplies, if you short it, they shut down, okay? I mean, I've done it. Because when this company here wanted to sell me more product, and we got talking about fusing and protection, their engineer said, take any power supply we have and go across it, okay? You will get virtually no arc, and it'll shut down, okay? And I did every single size they have and tried it, and I'm still here. And I have all my digits. Okay. But if you start getting further away from here, you gotta fuse that wire. You don't have a choice but to fuse that wire. If you got a bank of power supplies and your distribution's 10 feet away and you've sized your wire appropriately, you need to fuse where that starts making its trip. If you've paralleled a bunch of power supplies, okay, you can parallel the power supplies, okay, but as you start making that trip to wherever you're going, if it's more than a foot or two, you gotta fuse it. Protect it, breaker it, however you wanna do it. So, and, I state that, get more than a couple feet, fuse it. That's just what I was talking about. Fusing to meet the size of the cable. Each successive fuse, there's a calculator. Wire barn, it's a great little calculator. It asks you for 4 or 5 points of data, what you want. It'll ask you how far you want to go. It'll ask you what voltage drop you want, what voltage you're operating at, and it'll give you like out to tenths or hundredths of a foot what the size cable is and how far you can go. So it's a great little piece. Remember, wire length is calculated round trip, both directions. So that's 2 feet there in the grand scope of life. That's 2 feet there in the grand scope of life, not 1 foot. That's more, you need to bear that more in mind for feeders. The organ, they've set the parameters for the organ. 6 amps, 14 gauge return, okay? And that pretty much covers, whatever you're gonna do out there. There we go. What it says, 6 amps period, no more. Another gotcha, and Pat, I noted this specifically for you. I don't know how this applies, and you guys might wanna talk to somebody about pigtails on chest magnets. I could not, Bill, maybe you can answer the question. on a pipe organ chest magnet, you've got the coil,
Right,
and then you got two pigtails that come off there,
straight off the magnet wire.
straight off the magnet wire.
It may be counted as part of the component.
Okay. I could not, for love nor money, find something to address that.
I don't
So
know, yeah, inside the component's one thing.
this is
As soon as-
outside the
as soon as it
component,
leaves the component,
and the leads are added. The leads aren't the wire. The leads are added.
that's the problem.
There, I thought so. Okay. So Pat, you're probably going to have to consider a change. Yes.
So does that mean that every 40 or 60 ohm Reasoner or Wix action magnet needs to have a 14 gauge return
No.
wire going from it to your bus bar?
No. No. It's the connection to the device, but that device connection still needs to fall within the 26 gauge parameter. Okay. No, that would be impossible, impractical.
Right.
Right. No.
As a follow-up question to that, the Nylese wire that Peterson sells, although I think I've heard that they don't or aren't going to anymore, that cannot be used to drive drawn-out magnets then,
By the book, if it's smaller than 26.
which I guess it is. Technically, I don't know what size.
Is it
wire.
26 or 28, Pat?
26.
Okay. So it's okay at 26, it's not at 28.
Okay.
And they have sold both.
Right, yeah.
We have rolls of both downstairs, the Nileys that they sell,
Hmm.
26 and 28. If anyone wants
The
the
28s are for sale.
Yeah.
It's called beer money.
So, yeah, again, Pat, I mean, and Bill has kind of confirmed what my thought was, is that it's not internal, it's external, and it's separately applied, thus, you know, it's a gray area, you might have to do some digging. And if you get an opinion, get it in writing, seriously, you want it in writing. That was just one of the things that when I started reading this initially, I said, I gotcha. Spoke about the foil copper. If you're using foil, you got to make sure it's capable of handling, you know, basically the equivalent of 14 AWG.
Well, what do you know about the foil offhand?
Right.
It's the stuff you buy from Peterson 14 gauge?
I don't know.
The way you tell is you look at the cross-sectional area, and you just look those things up.
Okay.
Look at the thickness and the width, multiply it, look at the area of the foil, and then you look at a table for the 14 gauge wire.
I mean, they've told us in the past that it does.
Yeah, it's, the foil, anything, unless it's really aluminum foil thin,
No, this stuff is
yeah.
Okay.
pretty hefty. Just touching back on 650.3, again, if you're doing a combo, you've got Walker stuff, so on and so forth. I'll just make this statement: make Bob Walker install it and adhere to whatever code he's supposed to adhere to, and you guys don't be responsible for it.
Question about the 14 gauge return, and that's for magnets,
Yes.
and not necessarily for
Signal,
not for signal
Right.
feeds.
signal feeds, you can bring back. So resistive load.
Right.
Yeah, the switch common for all your drawknobs, for
Mhm.
example, can still be 28, 28, 26, whatever.
Some examples I penciled up, okay? Peter and I are gonna arm wrestle now. Pretty simple, a 5-rank standard EP chest with full of 120 ohm magnets, okay? And I've rounded everything up, so if you're running my math, you're gonna find everything is not to the decimal. 0.12 amp, worst practical load is 3.6 amps, 30 notes keyed. That's back to my 2 hands, 5 notes each, playing 5 different notes, not the same notes, in 2 different octaves with sub and super couples. Okay? And that brings you to a 3.6 amp load. Even if you played all, there you're only 7.3 3.2, as I refer to the 2x4 load. Easy wiring solution, 8A, I mean, I don't typically ever come out of a power supply with anything smaller than an 8. It's just, you know what, it's easy, it's cheap, it's guaranteed I'm never gonna have to think about it ever again, other than to, when we get further down, go back and retighten everything. But, and then one each 14 gauge per rank, 5, you can do individual 5 amp slow blows, and you've done that entire chest, pain-free. So, I'll ask the question: Is this scaring anybody so far? Is anything we've talked about here making you nervous as far as being able to comply? Because if so, we'll walk back. Because to be honest, like I said in the beginning, this is really pretty easy stuff.
And just to be clear, 120 ohms is an EP chest.
That's right. That's why I said 5 rank EP unit chest.
So this is, yeah, if you were doing a DE organ, you'd have way
Well,
more than
That's
5.
the next example.
Oh, okay.
Okay. Well, we're gonna get there. Okay, we're gonna get there. Okay. 7-stop Pitman chest. Okay, 61 notes, 150 ohm magnets, a 30 amp power supply. Magnet loads 1/10 of an amp. And I want somebody to tell me. There's a gotcha in my little example here. I want to see if anybody gets my gotcha. It's pretty simple. You can do a 10 from the power supply. Do a little power supply. Fuse as short as possible. Again, common per chest. Again, 5 amp slow blow, because you are, worst case. Anybody understand where I got the 3.7 amps from? Because
Stop action.
there you go. Okay, 7 stop actions in there. Okay, so not that hard. The next one, a little more complex. Okay, electric pull downs, 22 ohm magnets. You got a magnet load of 0.64 per magnet, okay, on the hairy edge of most control systems, okay. Your worst practical, not the Peter practical. and when we start talking about this after the break, you'll see why Peter and I've had this discussion ongoing. What's practical? What's extreme? What's just absolutely insane, okay? But 19.2 amps, I have not taken in consideration slider motors or whatever. Your worst case is 39 amps. Again, 8 AGW from power supply, 3 14 gauge per chest, 6 amp slow blow per feed, which gets you 18 amps. On a slow blow, it gets you probably 20% more forgiveness, okay? Rather than throwing another fuse in. Because again, I'm going back to what's the real world gonna be? But not that difficult to figure out. Here's a console. 35 stops, can't do a 15 amp power supply, so the next step is a 35. You could do it with a 15, but it'd be really, really, really close. Don't turn the light on. Okay. Okay. Worst practical load, all stops general cancel. You're 17.5 amps. 10 AGW in the small console. 3 commons, 12 stops each, 6 amp slow blow per common. An additional 1 amp fuse for your keyboards, pedal board. I'm an overfuser. I fuse everything, okay? If I got a common going somewhere, it gets a fuse on it, okay? Because it also gives me a way to break things apart, get them out of the control system loop. If I'm chasing a problem and want to test something, want to get in there with a light or something, chase something down, I don't have to think. I don't have to think whether I'm IOTI, Peterson, SSOS, whomever, am I gonna blow it up, am I not gonna blow it up? So, I'm a fuser. Put fuses in, okay, they're cheap. And it also gives you a way that, again, while it's hot, you can pop that sucker open, take that fuse out, take a lamp, go chase things. I was gonna do Holy Trinity, but
That's not enough draw.
I couldn't even think that big when I was doing it.
22 and 220 and 63.
Yeah. So this gets extreme. 200, a total of 240 actions. A mixed bag, half amp each. You're looking at 120 amps of surge when you push that button. Okay. 6 amp from the power supplies, doing 2 75s, again, six position blocks. You can do 8 from block to block to block if you want. How you fan it out is your prerogative. I'm a daisy chain kind of guy. It's easy. Because if you do a bus bar and then fan out, that gives you another level of complication because technically then you need to, again, still refuse every one of those subfeeds. Okay? Make you crazy. But the long and short is, 14 commons, 12 stops, so on. You can get by with 6 fuse positions, believe it or not. Light it up. But that's,
Wait a minute. 120
120 amps.
amps. That's only 6 fuses?
No, you know what, my math, I didn't put it in, it's 5 6-position blocks. 12 stops per position.
Gotcha. Okay.
6 amps, yeah, 6
Gotcha.
amp per position.
Okay, gotcha.
So-
Sorry.
I left a piece of it out in my dizziness. Again, additional fuses, 6 amps or smaller for lights, commons, this, here, there, that, the other thing. Again, fuse everything. Closing comments on this. Get yourself a copy of, if you don't want the book, you can go on to nfpa.org, National Fire Protection Association, and you can register. You can register yourself, okay? And you can have readable access to everything the NFPA puts out there. And it's NFPA 70 is what the NEC code is. Okay, 650 is the designation, but it's NFP 70. Make sure that you and your people all have a copy of 650 with you at all times. I would laminate the bloody thing, to be perfectly honest, and I would put it in every single service vehicle book that I have, if I were in the service business. Okay? Because the day's gonna come where somebody's going to say something and ask the question. So, hey, you've got it. And having it and being cognizant of it is going to be half the battle with an inspector. Okay? If you're sitting there saying, well, we wired it to code, well, then he says, what code? Because he isn't going to know the code. 99 out of 100 inspectors are not even going to know that 650 exists. They know the numbers there, but they don't know what it's about. So make sure all your people have read it and take the information today and make copies and have them read it. Again, it's not the law in itself, but it is the law as adopted by the enforcers and regulators. Okay? A sidebar on certain cities in our fair nation. Chicago, New York, Philadelphia, St. Louis. St. Louis is IBEW #1. Okay?
What's that stand for?
International Brotherhood of Electrical Workers, the union.
Should've known.
And the union and the inspectors in those big cities are like this, okay? Okay? Don't get in a pissing contest, okay? You go into an IEBW city, and we're going to talk quite a bit about that tomorrow, in how to, as I say, appliance ourselves from having to deal with a lot of this. But be aware that if you're in a city or in a jurisdiction, I mean, Appleton, Wisconsin was the one 4 or 5 years ago that lit up. And you scratch your head, it's Appleton, Wisconsin. Very strong code enforcement up there. Very, very anal, picky. This is the way we do things, don't argue with us, because we can make your life hell and cost you a lot of money.
Just out of curiosity, can you elaborate a little bit on that, what the problems were and how it was?
An organ was installed by a builder from out of state. I won't, I'm trying to parse my words as to, it wasn't necessarily workmanship work, okay? Electrical inspector came in from, I can't remember, I think it was the county. The organ builder decided to debate the issue. Okay? Mistake, 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 you're never gonna win. You may be right, but you're gonna lose, okay? He wanted the entire console gutted and started over. Paid inspector, okay? I saw pictures of it. It's not something that would have ever left my care and keeping, but from a pure functional standpoint, it probably was functional. From a practical safety, even remote code adherence standpoint, it was not. It was not fused. In the end, we learned it wasn't fused. In even the most rudimentary ways. The wiring was just, to be blunt, was a mess. Inspector took issue with it. He took issue with the inspector. It went all the way to Madison. It went all the way to the governor's office as part of the screaming over this. Okay? I think it was 7 months and $8,000 or 8 months and $7,000. Some combination of those two numbers before it was ever settled. Okay? It can happen. It has happened. There are other cases. Okay? I'm not going to get into all the things that I know from whom I know, but this is not a singular incident.
Was there an issue about an enclosure, things being in an enclosure too?
It was, well, that was another, and here's another aside, very innocuous. It was very simple. I am sitting in my office in Erie, Pennsylvania about 5, 6 years ago, and the phone rings, and it is Michael Laufer, People's Herzog. We got an electrical inspector in the suburbs of Chicago who's giving us a hard time, and your swell motor is one of his topics of discussion. Okay, well, you call him. Hey, in for a pound, in for $1 million, okay? What are you gonna do? So I pick up the phone and call the guy, and first of all, Michael tells me what church it's at, which immediately gives me a horrible disadvantage. It happened to be a church that my uncle and his family pretty much built some 50 years ago. But electrical inspector came on site. They were doing a rebuild and new swell motor, this, there. Electrical inspector's a member of the church. Okay, and he's up in the chamber looking at all this DC wiring. And neat DC wiring. Okay, Michael had sent me nice pictures and all. I said, man, this looks like good stuff. Okay, I'm not gonna lose sleep over this. I spent an hour on the phone with the guy. Talked to him about the code, but it started with all this, all that, and all major feeder cabling going in NEMA enclosures. Okay. Ultimately winding our way back, okay, to okay, it's okay. But it was, I think one of the gotchas was he wanted the swell motor fused. They had fused the swell motor externally. And since it was a long way, and I think about it, think about this yourself. the control system is over there in the bathroom, and the organ's over here, and the swell shades are there, and you've run this piece of, I don't know, 12 gauge, 14 gauge, whatever it is, you ran over to it, and it's stapled to the wall as you go to get over there. You have this piece of wire that has the maximum potential of whatever the power supply hung on the end of it is, exposed for somebody to run a knife into, hit with a hammer, whatever. So, and again, and you think every organ you've built is, up till recently, has probably been built like this. Okay? It's just the way it's been. But the long and short of it was, after an hour-long conversation and assuring him that, hey, it's all low voltage, and we got him on 650, because he was starting to cite low voltage code. And I said, well, you know, we do have a code. Would you like me to send you a copy of it? And we did that. And basically they went back and said, refuse a couple things, and he smiled and let him alone. Okay. You just never know. Okay. You know. Yes. Sir.
You talked about organs being like in its own box. What about an instrument that's, say, more freestanding, that stuff is not necessarily enclosed, it's just kind of out there? I have a Schlicker that's, you know, the pedal is exposed, and there, you know, other than the swell box, there is no...
Is it readily accessible by the public, I think, is kind of the measure. Okay, is somebody going to get on a ladder? Do you have to get on a ladder to get to it?
No.
Can somebody walk up to it and grab the cable?
Yes.
You'd probably lose the debate. Okay, Okay. Okay, I mean, you would probably lose the debate. If you roll back, where Art managed to get the magic, what the organ is.
Yeah, where the pipes are allowed to be the fence.
Yeah, exactly. That whole thing. Wrap your head around that. If you're outside of that, then you might want to think of at least PVC conduit. Even Smurf pipe will get you by, okay? Because it's enclosed, it's an added layer of protection, okay? But I think, I mean, judging from the notes that I got to read that Art had sent me early in this process, you could tell where there was this whole give and take going on about what was going to be called what. Okay, so we end up with the organ being perceived in a locked room or in a locked box, inaccessible, okay, by the normal passerby. Are you going to go back and rewire every organ? No. Are you going to go back and, okay, and that brings me to one very, very, very last point on this, and that's the ultimate conversation about cloth-covered cable. Okay. There are so many contradictions throughout the code on how this should be handled. Okay. Because if you step out, I mean, 650 says, ultimately, no cloth cable. Okay. Now you have to get into the nuances of grandfathering. One of the problems with 650, though, is it also doesn't address grandfathering anywhere. Okay. Other areas of the code, and then you've got that statement that says 650 rules over every other aspect of the code. My take, and others I have spoken to, and Bill, you're knee deep in this, I think, as from a non-understanding aspect. My take is, if you read other areas of the code that address existing wiring, even up to and including knob and tube, okay, by the book, undisturbed, and deemed safe, insulation still intact, yada, 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 so on and so forth, it can stay. Now, would I want that in my house? No. But there are nuances throughout the code as to grandfathering of things. If I were in your shoes selling organs and services and so on and so forth today, up till this latest reading and my spending, I don't know how many hours trying to decode this thing, my contention was, if you don't touch it, you can leave it. Okay? And that's pretty much been the belief.
I think we actually do get some benefit even from the 650 covers all.
Right.
Because when you're talking with an inspector, you can cherry pick. You can say, this defines that 650 covers organs, and organs are basically grandfathered,
Yeah.
therefore we're cool.
Yeah. I kind of have that same opinion. On the other hand,
I'm not gonna go to court with that.
that's right. On the other hand, and that's it. And this is in my world, and I'm an ultra conservative when it comes to protecting my best interest. Okay, Pat can tell you that. Okay, and the best interest of the company. As painful as it might be to say to somebody, that wire's got to go, I'd be saying that wire's got to go. Okay.
If you rebuild a chest, you probably have to replace the wire.
If you rebuild the chest and disconnect the wires, that's right. That's right. Again, it goes back to if you touch it, it's got to go. If you don't touch it, there's that gray area that says it can stay.
By touching it, what?
Re-terminate any single piece of it. If I got a 61 conductor, as an example, I just got done with a job in St. Petersburg where there's an old cloth covered cable that was serving the antiphonal. Now, we had no intention of reusing it to begin with because we're putting a relay addition in, but beside the point. If I had to lift any one of those wires off any one of those escutcheon pins, my view is I've just condemned the cable. Okay, and if you, pardon?
What about repair?
You can't repair it. It's non-repairable. It is non-repairable. And the real problem is, do you want that? You've done the work. A smart lawyer, a smart insurance adjuster, is going to drag you around the mud for a while trying to sort out what's real and what isn't. I would just, and I think the pitch ultimately to your customers is, for the best long-term interest and safety of your church, concert hall, whatever, it is, in our opinion, necessary to replace this wire. Oh, by the way, has the church been rewired? AC-wise. Okay? This is no different. I mean, it's up to your conscience, okay? Me, I'm the guy that I always want to err on the side that I did what was truly best in the interest of all parties involved. Hey, if it's a short run from here to there, and you know it's never been wet, and it can't possibly be walked on, and you're not touching any single lead of it, then I might say, okay. But anything more than that, if it's out of sight, if it's in the ground and a piece of conduit or something, I'd say plan B, man. So
Because the issue is cloth covered cable is going to unravel, the insulation will unravel, right?
it can deteriorate over time, and if it gets wet, that's the big thing. If it gets wet, it's part of the resistance equation, okay? And if it gets wet in the wrong place, it's never going to dry, okay? Ever going to dry. Matter of fact, it may begin to rot, and then
That lowers its resistance and it increases the heating capacity.
I mean, it's not good business. I mean, you go out there and spend $300,000 on putting a relay in, and you forego $2,000 of a cable change. or whatever the number is. So,
Again, I asked about the repair, I mean, I would need to replace one magnet in a chest. It's
as long as you don't remove the wire from the cable to the escutcheon pin, cut the wire on the magnet, solder the wire to the pigtail you left behind, put a piece of heat shrink on it, don't touch the wire feeding it.
Gotcha, okay, alright.
You can't even resolder the pin?
No,
Okay.
Nope.
that's a retermination. We're in agreement here. We got an EE sitting here, and we're in agreement. That's a retermination, and that's what I consider it.
You could take over Eric's job, is that what you're saying?
Vultures are circling.
Hi. we're gonna talk before the end of the day tomorrow. Yes, sir.
The stained glass people have a marvelous chemical they put on their tin and lead
Yes.
cane in repairing windows that darkens it so that it doesn't look like it's been violated. Just saying.
Touche. Yes, sir.
Bob, a question about existing conditions, like you were just talking about as it related to the insulation of the wires. But let's say, an installation, like you just assumed the care of an organ that has vinyl covered wiring, but no fusing, because it was done maybe 20 years ago or something like that. It's now under your care.
You need to dial back to the code 650, and it's been in existence for a long time. Dial back to the code that was in place at that time. Okay? I can quote 3 versions back, which is 9 years. I can't quote further back than that. But
It's never been allowed to be unfused, ever.
I know in low voltage code, there's never been a period of time where anything can be unprotected. So, you technically, under that condition, need to bring it up to at least the minimum standard of the time, which was fused at that condition.
I think just to broaden the question, assuming the care of an instrument that's non-compliant by code, is there an instant responsibility when you would assume the care of this non-compliant instrument to make it compliant, or?
The answer you don't want, the answer you don't want is,
Yes.
which
Even if you didn't touch anything in the electrical system.
the problem becomes, and that's a problem for our industry, because I don't know of very many organs that are fused. I mean, I just don't know of very many organs that are fused. And some that are, maybe were done 15, 18 years ago, where there was fusing on early control system driver boards, but that doesn't count. So it's a conundrum for our industry.
That would probably need somebody that is a lawyer to find out, because one of the things you may be able to do is simply write a letter.
Well, that's
saying,
why we want to hire you.
But you may be able to get by with a letter saying, this does not, we feel that this should be addressed.
Right.
It's in your best interest to do so.
Absolve yourself of the,
Yeah, see why.
But
You need to find a lawyer to find out
how to go
how
about
to
it.
how to cover yourself that way.
Well, doesn't that fall under the same heading as when you got the blowers, that they had the big lawsuits over years ago? And if you walk into a situation and you see they don't have a locked blower, that if you don't say, if you don't write a letter to them, then you're liable.
Yeah.
But as long as you've written the letter to them, would it fit into the same category?
Probably would, but again, as Bill said, I mean, hey, none of us in this room are lawyers. I mean, it was lawyerly enough for me to try to figure out truly all the nuances outside what's in print here, and figure out where the gotchas are, and it's kind of like the tax code. The bloody thing's 800 and something pages long. Yes, there's this giant disclaimer, but there are lots of contradictions, and that was one of the things that I struggled with was the contradictions. Could not some shrewd insurance lawyer say, your own code contradicts itself, we're going after you like this? And it's happened. I don't know, in our industry, I can tell you it's happened in telecom industry, when I was in telecom industry. And we were exempt in the telecom industry. If you were an operating phone company, you didn't fall under any of this, okay? Had our own set of rules. Western Electric, GTE, okay? If you were a utility, all that's gone now. Under deregulation, all that's gone, but back in the day. So, any other questions? We've burned up 90 minutes.
What would you say about a mid-50s molar that uses pushmatic circuit breakers, AC circuit breakers for DC protection?
It probably fills the bill except for the load size. Because I know exactly what you're talking about. I've seen
seen
those.
them.
Yeah.
Because they're not 6 amp, you mean? What do you
Well,
mean load side?
It's only feeding main distribution, big distribution.
Oh,
It's not feeding any sub-distribution.
So you're also saying that the breakers were rated for AC operation and not specifically rated for DC operation?
I know which ones you're talking about, the Bulldog Pushmatics, yeah, they probably were not. I've seen molars with intermatic toggles too.
I don't think it's not the right application for those
No.
devices.
No, and as a real quick aside, doesn't affect us because we're under 30 volts, but there are AC and DC type fuses, okay? In our voltage range, it doesn't matter, but if you're above 30 volts, further up, it can matter because of the way they arc and flash and do bad things. So, but if somebody says you want an AC fuse or DC fuse, always take the road, I want a DC fuse and I want a slow blow. So, I'm done.